Welcome back. This is section 5.3.1. We will be talking about counting principles. This is a continuation of the previous topic, so I highly recommend going over it. So, the first principle we will be using is the fundamental counting principle. That is, if you have A ways of doing one event and B ways of doing another event, together you can do both those events in A times B. So let's go ahead and take a look at the first problem here. So five companies have each sent one representative to a competition to pitch their newest business ideas to a group of angel investors. The conference has five time slots designated for one representative to present the company ideas. Okay? All right. So, how many different ways can the representative be ordered to present the ideas? So, every time you do a problem like this, I highly recommend putting yourself in that particular position. Now, let's go ahead and take a look how this is done. So, here I have five companies and five time slots. So I'm going to go ahead and give you those time slots. 1, 2, 3, 4, 5. Okay, I'm going to use a different color pen for the number of representatives. So it's representative A, representative B, C, D, and E. Now let's start with the first time slot. In the first time slot, how many options do I have? Because it's the first one, I can pick A representative, B representative, C, D, or E. So I have five time slots for the first slot. So it's five. Once that person's done, the next time slot doesn't have five because one person has presented already. How many options do I have? Four. You see that? So once the second time slot is done, how many options do I have? Three. Once that is done, I have two. And once that is done, I have one option. So the first time slot, I have five options. Second, four. Third, three. Fourth, two. And fifth, one, right? So how many ways can I do all of these together? Remember fundamental counting principle? I have to do the first time slot and stands for multiplication, and second time slot, and third time slot, and fourth time slot. So simply I will multiply the number of ways. So first time slot times second times third times fourth times the first. When I multiply all of these, what do I get? 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120 ways. Fair enough? All right, let's go ahead and take a look at the next one. A local restaurant offers daily lunch specials of one sandwich. Let me go ahead and use my highlighter. One sandwich, one side, and one drink for $8.50. For a sandwich, the customer can choose from chicken, turkey, and egg salad. So I'm going to go ahead and write that down. For sandwich, I'm just going to say sandwich. I'm just going to say sand. I can't leave it as sand, can I? I'm just going to say sandwich. I have three options. For the sides, let me go ahead and see how many options the customer has for the sides. They have potato chips, salad, or fruit. So I have three options: potato chips, salad, or fruit. For the sides, I'm just going to say sides. I have three options. Fair enough. Now for the drink, the customer has iced tea, Diet Coke, regular Coke, and bottle of water. So four options. For the drink, the customer has four options. Remember, now I can choose from three sandwiches, three sides, and four. How many ways is this possible? So that means I can do one chicken, one fruit, and a Coke, or I can do chicken, chips, and Coke. I can do chicken, fruit, and Coke. So there are multiple ways. Remember fundamental counting principle? If I have n ways of doing something, m ways of doing another, together I can do in m times n ways. So in this particular case, I can pick a sandwich in three ways. And stands for multiplication. I can pick a side for 3 and I can pick a drink for 4. 3 times 3, 9. 9 times 4 is 36 ways. Fair enough? All right. So the next one is a new word that you haven't heard before, which is called a factorial. So here, factorial of any number, factorial of a natural number n denoted by n and exclamation mark. So you write a factorial as n and exclamation. So exclamation in math means factorial. Is a product of all the natural numbers less than or equal to n. What do I mean? Let's say I want to find the factorial of 4. If I have to find the factorial of 4, I start with 4. It's the product of 4 times 3 times 2 times 1. So 4 times 3 is 12. 12 times 2 is 24. So 4 factorial is 24. Let's say I want to find the factorial of 5. So I start with 5 times 4 times 3 times, oops, I forgot to put a 3, times 2 times 1. Fair enough? So this is 5 times 4 times 3, which is 24 times 5, which is 120. All right. Let me minimize it. There you go. That's 120. And 0 factorial is always represented with the 1. So 0 factorial is 1. Now let's go ahead and see how we can use this factorial in finding the number of ways. So as you can see in the first problem, what we did was 5 factorial. If you can see the first problem here, it is simply 5 times 4 times 3 times 2 times 1, which is 5 factorial. Let's go ahead and take a look at the last problem here. Just trying to look at the screen to see if you all can see the entire problem. Yes, you can. 5 college friends are going on a road trip together for spring break. How cool is that? I think we all had the largest spring break ever, didn't we? For a spring break, and how many ways can they seat themselves in a 5-seat car? Use factorial notation. So let me scroll this up and hold this here. Yeah, can you see that? Yes, you can. So I have a 5-seat car, so I'm not going to attempt to draw a car, but I'm going to draw the seats. So I have 1 seat, 2 seat. No, you can't see that. So I have 1 seat, 2 seat, 3 seat, 4 seat, 5 seat. So there are 5 friends, right? The first seat is just like the one we did problem 1 before. The first seat, how many of them can sit? How many options does the first seat have? If there are 5 friends, any of the 5 members can sit on the first seat, right? So it's 5. So once one of the members sat on the first seat, I have 4 seats left and I have 4 members left. So the second seat has how many options? Any of the 4 members can sit on the second seat. You get the idea? 4. What about the third seat? 3. Second seat? 2. And the last seat? 1. Remember, I'm trying to find the number of ways. I'm trying to see how many ways can they sit in all 5 seats. So the first seat and the second seat and the third seat and the fourth seat and fifth seat. I am repeating the word and because you know every time I say and, it's multiplication. So it's first seat and second seat and third and fourth and fifth. So 5 times 4 times 3 times 2 times 1 is nothing but your 5 factorial. All right? Okay, now let's go ahead and take a look at the next problem. All right, so sometimes they ask you to, let me see if you can see this. Yeah, you can. Let me extend it just a little bit. Yeah. A standard deck of cards has 52 cards, okay? If you draw one card at a time from the deck of cards without replacement, how many different ways can you draw all of the cards? Remember, you're not replacing it. So give me 1 second here. I think I have a deck of cards available. Oh, I made sure I got these for you. These leaves are so irritating. Okay. All right, let's go. So we have a deck of cards. These are 52 deck of cards, right? So I have 52. What am I doing? What are they asking me? They're asking me um, if you draw one card at a time from the deck of cards without replacement, how many different ways can you draw all the cards? So here I have 52 cards. So the first card, I'm drawing all 52 cards. The first card, how many options do I have? I can draw the first one, the second one, the third one, the fourth one, the fifth one, right? So if you can see here, I hope I'm holding it right. If you can see from the deck of cards, I can pick any of the 52 cards. So for the first one, I have 52 options. So let me go ahead and do that. So the first one, I have 52 options. So first, second, third, fourth, I'm not going to draw 52 lines, but you get the idea. So the first one has 52 options. So let me say I'm just going to close my eyes and pick. I don't care which one I pick. So I'm just going to pick one. So from 52 deck of cards, I picked one. There you go. Second, how many options do I have? Remember, I picked one card already. So how many cards do I have? From 52, if you take away one, the next card has 51 options. So 51, you see that? I'm going to take this one. The next one has 50. I'm going to take it off. Boom. The next one has 49. So you get the idea, right? So you go 49, 48, 47, so on and so forth, all the way up to 1. And remember, when you multiply, they're asking you how many ways can you pick all the cards. That means you have to pick the first card and second and third and fourth. So it's 52 times 51 times 49 times 48, so on, going all the way up to 1. And that is nothing but 52 factorial. All right? There you go. Again, please take your time to think about the problem, see what's happening, and then start working out. Okay. Now, counting with permutations. Now, this is a new term. As we go deeper into the topic, you will have another word that says combinations. So you have to very clearly understand the difference between permutations and combinations. All right. So what is a permutation? A permutation is an arrangement of elements where the order matters. You always think about permutation as a race. Who is coming first, who is coming second always matters, right? I can't say two people won in the race and not tell you who those two people are, because definitely the order matters. Who's coming first, who's coming second. So permutation is an arrangement where the order definitely matters. As we do more examples, you will understand them better. So let's take a look at how permutation works. Again, you need to have all these formulas on your note card so it becomes easy for you when you're taking your test. All right, the number of ways of selecting R items from n different items when the order of selection does matter. So, how do I give a best example? Let's say you have to pick a president, a vice president, and a secretary of a class. Definitely, let's say I'm the secretary and you're the president. That's one way of doing it, right? And I'm the president, you're the secretary. That's another way of doing it. So you see, the position and the order does make a difference, and that's permutation. So every time you do a problem, you have to think, does it make a difference? Who comes first? Who comes second? Is that a different arrangement? Is that a different permutation? Then yes, you use permutations. All right? So number of ways of selecting R items from N items where the order of selection does make a difference is called your permutation. And the way you notate is N, P, R. That is, you are selecting R from n. All right? And the formula is simply n factorial over n minus r factorial. What I will be doing is I will be doing the problems mathematically, solving them, and also using your class calc so you can see how the how the factorials are done. Let's go ahead and take a look at the first problem here. Let me scroll this up. There you go. There are 6 statistic instructors in mathematics department at a college. Let's take our college, all right? If your major requires you to take 2 statistic courses, how many different ways can you have 2 different instructors from these classes? Remember, you have 6 statistic instructors. I have to pick 6 colors. All right. So 1, 2, 3, 4, 5. Can you see that color? 6. So you have 6 statistics instructors. Let's say I am yellow because I'm wearing yellow today. How many different ways can you choose? So you can take, let me pick a black color here. So you can take red as your first class and blue as your second class. That's one arrangement. Or you can take blue as a first class, red as your second class. That's another arrangement. Or you can take red, yellow, that's 2 different classes. Or yellow, red, that's 2 different classes. As you can see, which class goes first, which class goes second. Just like when you're doing your schedule, you always make sure you're taking the classes where you have enough time to study, right? So just like that, your statistic courses with 2 different instructors, if your first class is at 9 o'clock, the second class is at 11 o'clock, that's an arrangement. If your first class is at 9 o'clock and the second class is on Tuesday, that's a different arrangement. So the order definitely matters. Again, when the order matters, it becomes a permutation. So let me go ahead and put it in simple terms. So first thing you will think about, is it a permutation? Yes, it is. So the way you write is, you know it's a permutation. So look at the way I'm writing it. So I'm going to start with a P. It's a permutation. I am choosing 2 classes from 6. I'm choosing 2 classes from 6 classes. So 6P2. Now if I am going to, let me go ahead and erase this. I'm going to move this here. So this is 6P2. And I'm going to solve this mathematically. Remember what 6P2 means. What's the formula for permutation? The formula for permutation NPR is n factorial over n minus r factorial. So that is 6 factorial over 6 minus 2 factorial. I'm going to expand it so you can see. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 6 minus 2 is 4. So 4 factorial is 4 times 3 times 2 times 1. And if I cancel these, 6 times 5 is 30. So I have 30 ways of choosing 2 classes from 6 classes. How cool is that? Now let me go ahead and pull up my class calc and show you how to work this out in class calc. Give me 1 second here. So here I have my class calc. I'm going to go ahead and plug in 6P2 so you can see. So I'm simply going to stats. And as you can see, I have NPR. I'm going to go ahead and click on that. The first variable is your n value. In my case, it is 6. And the next variable is r. So in my case, it is 2. And as you can see, NPR is 30. So it's as simple as that. You simply go to your class calc, click on stats, and then click NPR if you have to find the permutation. All right. Now let me also show you how to find your factorial. So if you have to find factorial of 5, you simply click 5, go to your class calc, and then you see this exclamation mark? That is your factorial. Simply click on that, and there you have it, 120. All right? Now let's go ahead and take a look at the next problem. Can you see that? Da-da-da-da-da. Yes, you can. A car race typically has 36 race cars. It's a race. So who comes first, who comes second is an arrangement. Who comes third, who comes fourth is an arrangement. So the order does matter. How many ways can those cars place in top two to finish? So I'm only looking at two cars, the first position and the second position. How many cars do I have? 36. So this should be your thought process. First thing, does the order matter? Yes, it does. It's a race. So who's coming first, who's coming second definitely matters. So it's a permutation. Okay, so here you go. It's a P. Can you see that? Yep. It's a P, right? And hold on one second. Yeah. How many cars am I choosing? I'm choosing two cars. From how many cars? From 36 cars. So 36P2 is your answer. Sometimes they will ask you to leave it at this notation. Sometimes they'll ask you to work it out. If they ask you to work it out, you simply go to your class calc. Where is it? Boom, class calc. I'm going to delete all of this. Uh, Stats, NPR, 36, and the next one is 2. Oops, wrong place. 2. So it's 1260 number of ways you can have different permutations of who's coming first and who's coming second. So again, it depends on what they're asking you. I'm guessing majority of the time they ask you to leave it as a P. If they ask you to work it out, then you simply go ahead, plug it in your class calc. All right? All right. Now, next one. A youth basketball team is made up of 7 girls and 6 boys. My highlighter, 7 boys and 7 girls and 6 boys. The coach assigns 5 players at a time to specific positions. Basketball, do they have forward, defense? I don't play basketball, so I'm guessing they have different positions in basketball. So the coach is assigning different positions in basketball. Okay, how many ways can 13 players be assigned to 5 different positions? So there are only 5 positions, and I have 13 of them. So step one, think. Does the order matter? Yes, because I am assigning a specific position. So if I have to play forward, do they play forward? So let's say I have to play forward or defense or whatever positions are in basketball. So if I'm playing that position, you play the next position. Somebody else plays the other position. So that's a different arrangement. If I'm playing defense or I'll look it up. Let me ask my kids what positions they have in basketball. All right, check with my boys. So there is center, there is point, I forgot. So there is center position, there is point guard position, and there is, let's say, defense position. Okay, so they're all these 3 different positions. So me playing in the center, you playing in the point guard, that's a different arrangement. I'm playing in the point guard, you playing in the center, it's a different arrangement. So when they specify positions, so that means that's a different arrangement. It's a permutation. Okay, so what am I doing? I know it's a permutation, so I'm going to put a P, wrong pen. P, it's a permutation. How many am I selecting? I'm selecting 5, right? From how many? 7 boys, 7 girls, and 6 boys. So altogether, 13 of them. So from 13 players, I am permutating or I'm selecting 5 players with different positions. So it's a permutation. 13P5. Again, if they ask you to expand it, you will go ahead, plug it in your class calc. All right, let's go ahead and take a look at the next one. All right, so the next one is, now that we've seen permutations, the next topic is combination. So combinations, what does combination mean? Combination is grouping of items in a set where the order does not matter. Let me give you an example. Let's say you have to pick a committee of 3 members. So if I pick you first and if I pick myself second, it still doesn't matter because we both belong to the same committee, right? So the order does not matter because there are no positions. We are just members of that committee. So when the order does not matter, then it's a combination. The best example is like putting your stuff in a salad bowl. First, you put your lettuce, then you put your cheese, then you put your tomatoes, then you put your onions. So it doesn't matter what goes first into the salad bowl because you mix it all up and eat it all together. So it doesn't matter. The order does not matter. So think about this. It's a silly example when you are working with combinations. It doesn't matter what I put in first into my salad bowl. Everything is going to go right in, right? So that's a combination. You're just mixing everything up. It's a combination. The order does not matter at all. Let's take a look at the example. So first, the definition of combination: the number of ways of selecting R items from N different items, where the order of selection doesn't make any difference, is your combination. And the way you notate your combination is C, so NCR. Permutations is P, so NPR. Okay? And the formula for your combination is NCR is simply n factorial over n minus r factorial. There's one more extra times r factorial. You can always go ahead, plug this in your class calc as well, but we will do one problem and then I'm going to show you how it's done in your class calc. All right, let's see. A child randomly selects 5 toys from a bin. So there's a whole big bin of toys, and the child randomly selects 5. And in that particular bin, you have 3 bunnies, 5 dogs, and 6 bears. So the first step is to see how many are in that bin first. So 3 plus 5 is 8. 8 plus 6 is 14. So in that big bin, I have 14 toys. And the child is picking 5 toys from the 14 toys. Again, what the let's say the child picks 3 bears, or do we have bears? Yeah, 3 bears, 5 dogs, or 2 bunnies. Does it matter which bunny comes first? No, it does not. It's like a salad bowl. You're putting everything in the bowl. It doesn't matter. The order does not matter. So as soon as you know that the order does not matter, you know it's a C, which is combination. How many how many toys are you picking? You're picking 5 toys from the big bin. But how many are there in that big bin? There are 14 of them. Fair enough? 14C5. So the way you do this is mathematically, it is 14 factorial divided by 14 minus 5 factorial times 5 factorial. You can go ahead and work this out, but I'm going to show you how to plug this into your class calc. So let's go ahead and pull up a handy dandy class calc. Boom, there we go. I'm going to delete this. Um, so I go to stats. Remember, when you're using your NPR or NCR, it's your statistics. So stats, it's NCR, remember? Because it's a combination. What does my N stand for? The N is always the bigger number. So in this my case, I have 14 toys in the bin. How many am I picking? 5. As you can see, that child can actually pick in 2002 ways. Try telling this to a baby. You can pick this in 2002 ways. Okay, so it's 2002. I'm guessing the homework does not ask you to evaluate, just ask you to give in the combination or the permutation notations. All right. Let's take a look at the next one here. Let me close my class calc. A computer-generated password uses 3 number digits and 8 lowercase letters, okay, without repetition. So what's happening? A computer is randomly generating a password. So you have to use those numbers and alphabets to make a password. So the generated password uses 3 numbers, so 3 numbers and 8 lowercase letters. without repetition. I think the question is missing. The question says, how many ways can this be done? How many ways can this be done? Remember, you are not generating a password. You are saying how many ways can the computer generate 3 digits and 8 letters. Okay? It can be any 3 digits. Excuse me. It can be any 3 digits. So how many digits do I have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 digits. So 10 digits altogether. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So from these 10 digits, computer can randomly pick any three without repetition. From the alphabets, from A to Z, the computer picks 8. Okay, so now I want you to pause for a second. You are not only picking the letters, but you're also picking the alphabets. The key word is you're picking the letters and the alphabets. So when I say and, what comes into your mind? Multiplication. So let me erase this here. So you have to pick your numbers and your letters. For numbers, it's a combination. Remember, it doesn't matter what I'm picking. So it's a combination. So I'm picking 3 numbers from 10 numbers. And I am picking 8 letters from 26 letters. Fair enough? Let me rewrite this a little bit bigger. So numbers and letters. I know both of them are combinations, right? I am picking 3 numbers from 10 and I'm picking 8 letters from 26. There you go. I don't think they'll ask you to multiply this. They're just asking you for the combination notation. So you simply go ahead, plug this into your value. So I'm picking 3 numbers from 10 and I'm picking 8 letters from 26. Because I have to pick numbers and letters, it's a multiplication. All right. Let's go ahead and take a look at the next one. Let me minimize this so you can see it. There you go. Dental students at a university must choose 2 classes from natural sciences each semester and 3 classes from dental school. There are 13 natural science classes offered each semester and 18 dental school classes offered each semester. Now, they're not asking you for the order. They're just saying choose 2. So when they say choose 2, you can choose any 2. If they talk about what does your schedule look like, then the order does matter. In this particular case, you're just choosing. So automatically the word choose tells you that the order does not matter. So what am I doing here? I am picking, let me use from my natural sciences. From my natural sciences, I have to pick 2 classes, right? So how many natural sciences? I know it's a combination, right? I'm going to write a smaller c. Yeah. So I know it's a combination. From my natural sciences, I have to pick 2. But how many classes do I have? 13. And multiplication. From my dental, again, it's a combination. I have to pick 3 classes. And how many do I have? 18. Fair enough? All right. All right, let's go ahead and take a look at the next one here. A bingo game has 100 white balls with each with the number 1 to 100 on them. It also has 23 red balls, each with the number 1 through 25 on them. Each time the game is played, 5 white balls and 5 red balls will be drawn. So 5 white balls, 5 red balls will be drawn. 5 white balls and 5 red balls. Keep in mind the word and is very important because if you miss that little clue, then the whole problem is gives you a wrong answer. Use the template below. They said use the template below. That's very nice of them. They ask us to use the template below to calculate the answer. Again, what am I doing? I am drawing 5 red balls and 5 white balls. Okay, without repetition, keep in mind. Okay, so I'm just going to put this here, move this up as much as I can. All right, come on. Okay. Um, this is not letting me do that. All right, so that's fine. I am picking, it's a combination. I know it's a combination, right? From 100 white balls, I am picking 5. 100 C5 times from 25. Why am I writing it here? From, oh my God, okay. From 100, can you see that? All right, just give me 1 second. There you go. It's much better now. Okay, from 100 white balls, I am picking 5. It's a combination. It doesn't matter which white ball I pick. No, it's just 5 white balls. And multiplication. From 25 white balls, I am picking 5. The order does not matter. So there you have it. 100 C5 and times 25 C5. All right, let's see if we have. No, that's the end of this topic. Again, if you have any questions or comments, please email me, reach me through Teams, or you can comment in this video below. All right, take care.